get this meeting started. We are recording the meeting so that other people who aren't here will be able to watch it later. So I want to thank everybody for joining us this morning to learn more about this Woodcock Priority Area Siting Tool. This is a project that we developed with the University of Maine. We've been working with them on an Eastern Woodcock migration study, where we've been putting transmitters on woodcock in Pennsylvania, and other states have been doing the same. And this is a spur from that project where we wanted to look more at habitat use within Pennsylvania. So we want to say a great thank you to our partners, Dr. Eric Bloomberg, Dr. Amber Roth, and Liam Berrigan. Okay, he's a PhD student on this project and has been doing the bulk of this work. And they've been working closely with us and folks in habitat management, Scott and Tim, to really develop this and make this product what we think is going to be pretty useful to you guys. So with that, I'm going to turn it over to Liam and let him go over the Woodcock Priority Area Siting Tool.
Great, thanks, Ken. I'll share a screen real quick. All right, well, thank you all for coming today. I'll be giving a brief overview of what WPAST is. As like Ken said, that stands for Woodcock Priority Area Siting Tool. And then I'll go a little bit further into how to use it and kind of how all the various little doohickeys in the application work. But as Ken said, this really came out of a large-scale collaboration that Pennsylvania has been a part of since essentially the beginning, which is called the Eastern Woodcock Migratory Research Cooperative, which is this group of 34 organizations. This includes federal agencies, state agencies, nonprofits, universities, et cetera, that have all come together to try and study woodcock ecology throughout Eastern North America. And so this has largely consisted of catching woodcock and attaching little satellite transmitters to them, which will then broadcast the woodcock's location and status back to us wherever the woodcock happens to go. And so this really allows us to gather this really unprecedented level of information about woodcock survival, habitat use, migratory connectivity, et cetera, that we can use to learn a whole lot more about woodcock migration. So the cooperative has so far deployed over 450 transmitters throughout Eastern North America. 49 of those transmitters have been deployed in the state of Pennsylvania since 2018, which has been a really big part of this effort. And so what I'm going to show you today is largely from both those tags, from those birds that have been tagged in Pennsylvania, but also woodcock that have been tagged throughout the rest of Eastern North America that have then migrated through and stopped in Pennsylvania as well. And so this project has allowed us to get this really unprecedented level of information about woodcock habitat use, which I can show a little bit about here. So this is a animation of woodcock tagged in the state of Pennsylvania as they move south in the winter. So this is both all birds tagged from fall 2018 through fall 2021 and their movements south into their non-breeding states. But this has really allowed us to essentially create these large-scale statewide habitat models that we really couldn't do before this, just because we have all this new information about woodcock stopover sites, and we can create habitat models using the same fidelity that we'd essentially expect for breeding models. And so this is important because Pennsylvania isn't really just a breeding site for woodcock, although it has a fairly large role as a breeding site. So here we have a range map for the American woodcock. In blue here we have its breeding range, and orange is non-breeding range. Green is the overlap between the two, and yellow and purple are those areas that are outside the breeding and non-breeding range but still have woodcock during the non-migratory season. These black contours here are woodcock migratory hotspots. So it's where woodcock have a tendency to stop over during their migratory flights. And so you can see this outlines this area that woodcock move up and down the East Coast during their migratory flights in the spring and the fall. So if we zoom in on the state of Pennsylvania, we can see that the majority of the state of Pennsylvania is breeding habitat, but it also, in the eastern portion, hosts a whole lot of migratory stopovers. Plays a fairly large role in these woodcock that are moving up the East Coast to move into northern New England, as well as New Brunswick, Quebec, Nova Scotia, where these very large woodcock populations are. So Pennsylvania isn't just this really big breeding state for woodcock, but it also plays this really much larger role as this migratory corridor for woodcock throughout New England. So now I've talked a little bit about the motivation for WPAST and the motivation for a tool that has the ability to really model woodcock's use of Pennsylvania throughout migratory and breeding seasons. I'm going to talk a little bit more about what it particularly is. So Woodcock is a tool, an application that takes landscape scale factors into account when trying to determine where woodcock habitat management is most likely to be successful. So to do so, it takes several suites of factors into account in order to try and predict where woodcock habitat is likely to be. This includes landscape configuration. So how large is a certain patch of forest and how well connected is that patch of forest to other patches of forest across the landscape? Land use, land cover, how much developed land cover is there within a certain distance of a point, how much agricultural, how much forested, et cetera. It takes topography into account, hills, ridges, mountains, plains. Those areas tend to, woodcock have certain preferences for topography, and this takes that into account during the modeling. And finally, soil drainage or soil moisture. So essentially, how wet is a certain area? Because we know that woodcock like earthworms, and they tend towards these more wet areas in order to find them. So WPAST takes all these suites of predictive variables and it uses them to make season-specific predictions. When I say season-specific, I mean it creates a separate layer for the breeding season and another layer that encompasses the two migratory seasons. So woodcock, like most migratory birds in North America, can really be simplified, have their annual cycle simplified down to these 4 seasons, this breeding season and this non-breeding season, but also spring and a fall migratory season. WPAST is creating a separate prediction layer for the breeding season and for the migratory seasons. So what it does is it lumps that spring and fall migration together into a single category, just because we have been seeing similar habitat use during both those periods, so that we can look at those in just a breeding and a migratory context. So some real quick definitions before we go any further. For breeding season, we're considering that to be a habitat used between the spring and the fall migrations, so between May 15th and September 15th. Woodcock are doing a whole lot of different things during that period. They're mating, they're laying eggs, they're nesting, they're incubating, and then brood breakup. That being said, woodcock have a tendency to stay within the same general area, at least in a landscape scale perspective, during this entire period. So we feel comfortable lumping habitat use, at least on a landscape scale, during that period altogether. So to predict where woodcock are going to be during the breeding season for our models, we use data from the federal sitting ground surveys, as well as the Pennsylvania Game Commission specific woodcock surveys that you all have been conducting, which use fairly similar methodologies in order to determine where woodcock are, at least during the displaying periods. So for the migratory seasons, what we're referring to for habitat use here is areas used when resting between these nocturnal migratory flights. So woodcock, like most migratory birds in North America, tend to fly at night. When daybreak occurs, they find an area where they can stop, where they feel fairly safe to rest, refuel, and avoid predation before the next migratory flight occurs. So this can sometimes be areas that are fairly similar to those areas where they might spend time during the breeding seasons. Often, as this picture illustrates, these areas can be quite different. So for example, we have a whole lot of woodcock stopping over in Philadelphia, in the Philadelphia suburbs. Sometimes these woodcock don't find good stopover areas, as the sidewalk illustrates, but oftentimes they find parks, brownfields, other green spaces in these urban areas that can be fairly important for their survival and for them making it to the next step of their migration. So for measuring woodcock habitat use during the season, we use these EWMRC tag birds I talked about earlier and their GPS locations to determine where woodcock are stopping over during migration and to model that habitat. That includes both Pennsylvania tagged birds and birds tagged in other states that are then migrating through Pennsylvania. So the outcome of this is we end up with a migratory season layer and a breeding season layer for predicting where woodcock habitat potential is going to be. What WPAST then does is it takes those two layers and it blends them together based on a user specified weighting system that determines essentially how much the user values migratory season habitat versus breeding season habitat, at least for their management plan. And so this is largely left up to the agency and the land managers to really decide for themselves how they'd like to manage these two habitat types. This can be based on agency-specific priorities, local/regional abundance of habitat. Let's say there's this one little island of area in a region where there's a high potential for migratory habitat. Maybe that's the type of area that you as land managers would like to conserve. It also allows you to take migratory corridors into account. So for example, as I showed earlier, there's this really nice migratory corridor running through eastern Pennsylvania. Maybe that's an area where you'd like to conserve more migratory habitat. But this is really all left up to the agency and to land managers to really decide on their own how they'd like to decide on this weighting. At this point, I'm going to transition over into a demonstration of how to use the app and how all those various tools work. So this URL will be shared after the presentation. But when we open the application, it first lands us on an instruction page, which provides a little bit more detail about the application and its use. So over here to start with, we have some directions. Tell us a little bit about the intended use of the app, its limitations. One of the limitations, which I'll address specifically, the limitations tend to be in bold down here, is that this model, what this model does is it accounts for large-scale landscape characteristics to determine which areas have the highest habitat potential for woodcock. So for example, this application might highlight an area as having very high habitat potential, which is actually mature forest, and there really aren't any woodcock there. So this application doesn't tell you where the woodcock actually are. It tells you where woodcock could be if appropriate management was conducted. So that little island of mature forest might not have a whole lot of woodcock there, but if you took that mature forest and you manage it for woodcock, and you put in place all these various early successional habitat measures, that area has a very high probability of hosting woodcock after that management occurs. So that's a fairly important distinction, which is why it's in bold down here. And that's stressed a lot in the manual as well. And if you have any questions about it, I'd be more than happy to take them after this presentation. So that's the directions panel. We also have user guides over here. The user manual is live, so you can click on this and you'll get a PDF of the manual, which talks about a lot of what I'm going to talk about in the next 10 or so minutes. The recording from this presentation will also be here after I upload it. And some credits down here saying where all this data came from and a link to other EWMRC resources. And when we're done, we can access the app using this button here. If we ever need to return to this screen, we can do so using the orange bar at the top. So this leads us to the application page. The map may take a second to load. I find this tends to be very internet connection dependent. So if you're on a bad internet connection, please do give it a couple minutes, or not a couple minutes, but a couple seconds. But this here is the application page. This is really where the magic happens. So over here on the left, we have a sidebar, this gray area here. This allows us to modify the settings that generate the map and really modify those to modify the weighting, the layer view, which I'll go into a little bit more specifics in a moment, to really generate what we see over here on the right. And this portion of the screen is called the map viewer, which we can use to actually look at the map. So going into a bit more detail about the sidebar real quick, we have two orange tabs at the top. The first on the left is the layer and weight tab. This allows us to actually modify the settings that generate the map. On the right is game lands within view. That allows us to view statistics about the state game lands that are within the map view. And we'll go into that in a bit of detail in a moment. But to start with, the layer and weight tab has two real mechanisms for modifying the settings on the map. We have the layer view up here and migratory and breeding weight down here. So layer view has three options. The top one, statewide layer, is the one that we have currently activated. And so this generates the statewide predictive surface that shows how the potential for an area to host woodcock varies across the state. And so this is scaled from 0 to 100 on a percentile scale. So for example, a pixel with predictive value of say 58, which would show up as roughly orange here, would have a higher chance of hosting woodcock than 57% of the other cells in the map. This layer also responds to changes in weighting, as just about everything in WPass does. So when you change the toggle setting down here in migratory and breeding habitat weight, that will change the layer view. It will change, or sorry, that will change the predictive layer as you're seeing it. It'll change statistics. It'll change pretty much every aspect of the program that you're seeing. But we can toggle this to a different one. It'll think for a second, and it will display the predictive layer under a different set of weighting conditions. Moving on to the next layer view option, we have game lands, looking at it from a landscape suitability index perspective. So landscape suitability index takes the pixel value that we saw in the predictive layer earlier from all across a particular state game land. It averages it together, and then it multiplies that value by the acreage of the game land. And what this does is allows us to determine which game lands have the greatest total potential to host woodcock within their borders. This is useful because it allows us to, of course, pinpoint those areas which might have more total habitat potential for woodcock. That being said, as you can see here, it tends to bias more towards these larger game lands and away from these smaller game lands. So it's important to take this statistic into account with a whole bunch of the other statistics that I'll brief you on in a second when comparing these larger and these smaller game lands. This also responds to changes in migratory and breeding weight, just like the other one did. Our final layer view option is average pixel value. So this displays the game lands again, but it scales the color ramp based on average pixel value instead. This is just those pixels from the predictive layer extracted for each game land and averaged all together. So what this does is it allows us to determine which game lands have the highest average suitability value. That being said, it tends to bias more towards really small game lands like this one over here, which just have a lot of woodcock habitat on them. And so their average predicted value is high. That being said, if you run into these larger game lands, such as game land 12 right over here, that still have a fairly high average pixel value, that's a very good sign for woodcock habitat management. So I've talked about migratory and breeding habitat weight to some extent already. This allows user-defined rating of woodcock migratory and breeding season habitat. You can weight it in 10% increments based on your liking. That being said, if you're just interested in migratory season habitat, I'll switch back to the predictive layer for this. What you can do is switch to migratory 100% and breeding 0%. And so this will show you what would happen if you solely managed for migratory habitat or if you solely managed for breeding habitat. As you can see, there's a fairly different resolution of prediction for migratory and breeding habitat. This largely comes down to woodcock ecology and kind of the scale at which they're making predictions. At least woodcock are making habitat decisions. That about finishes up for the layer and weight tab. We'll now move on to the game lands within view tab, which shows us the statistics for all game lands which are currently within the map viewer screen. And so if I zoom in here on these game lands, the table here will adjust to only show those game lands which are currently on the screen. If there's a particular game land I'm interested in, let's say I'm interested in game land 12. Oops, wrong one. I can type in the search box up here and it will filter. I can then click on results in the table. Those will be highlighted on the screen. Let's see, anything else here? Also, definitions for each of these statistics, although I talked about them already, are available by hovering over these titles here. And these definitions are also available in the application manual. So let's say I'm particularly interested in game land 12 over here. If I want more details about that game land, I can click on it and statistics will pop up. The statistics that pop up are dependent on the layer selected. So here, if I switch from statewide layer to average pixel value, these statistics will change to include average pixel value statistics. So here we have the game land name up here, the average pixel value here. Percentile indicates the percentile ranking of that game land's average pixel value, because that's what's being displayed. So for example, game land number 12 has a higher average pixel value than 78% of other game lands within the state of Pennsylvania. We also get two other statistics, which I have not introduced yet. High suitability indicates the number of cells within game land 12, which have values between 64 and 100. Moderate suitability is the number of cells that have values between 34 and 66. And all this information is available down here in footnote number 4, if you forget it. Also available in the application manual. Let's see. And that about finishes it up for the application. There's one more interesting thing about the map viewer that I wanted to go over. Of course, you can zoom in, zoom out here. Legends is up here, but if you want to change the maps that are visible within the map viewer, you can scroll over these stacked layers over here on the right, and a menu will appear. This allows you to toggle between topographic map and the satellite map, both using default Esri layout. You can also turn on and off the state game lands if you decide to do so. So that about concludes my introduction to the WPASS program. And if you have any questions, I'll be happy to answer them. Thank you. Also, we will show the link.
Thanks, Liam. Could you pull up the application again and just spend more time on what it looks like for 100% migratory and 100% resident? Because there's pretty big differences. And I know a lot of people are out there doing our Woodcock surveys, and they're doing it during the breeding season. So some of these places where they may be doing habitat management, they may not be seeing a lot of woodcock because it's just not in the right spot for breeding habitat, but they can still, those areas still may be providing useful habitat for woodcock, but it may be during migration, which is when we're not out there surveying. So there you can see that there can be pretty big differences depending on where you're at the state, whether it's better for migratory or resident breeding.
Yep, especially certain regions. As Ken pointed out, there tends to be a lot of regional differentiation in the breeding maps. So you can see here, there are certain regions, especially southeastern Pennsylvania and the area around Pittsburgh, I believe, where there's just really not a lot of breeding habitat. But all of a sudden, once you move to the migratory model, those areas have a whole lot more options available.
So Steve Bernardi asked if you can overlay high migratory stopover areas and state game lands.
Let's see. Sorry, overlay within?
High migratory stopover areas and state game lands. So I guess click on the 100% migratory.
Okay. Oh, gotcha. Yeah.
Would you want game land view then, Liam, as well?
Sure, we can switch to game land view. Landscape suitability index. Yeah, so there are a fair number that are fairly highly ranked for migratory.
And Samara has a question about game land size and suitability in the model. Go ahead, Samara.
I tried to type it and I was like, yeah, that's not going to work. So I thought I heard earlier that you mentioned that certain management schemes, small game lands may not be as appropriate as large game lands. But my question is, there are a lot of places where we have multiple game lands that are contiguous with each other. Mm-hmm. Administratively, they're different. So I'm wondering if the model is able to recognize those sort of one game commission owned area, or if they're only being recognized for their smaller administrative sizes and how that might bias the model. Does that make sense?
Yeah. First, so just to clarify, so the kind of larger versus smaller game lens from our perspective, really, so what it does here is it changes the landscape suitability index and the average pixel value, just because, so landscape suitability index measures the total amount of habitat that is within that, well, the total amount of habitat potential area within that game land. And so larger game lands are more likely to have a higher landscape suitability index for that reason. It kind of biases towards these larger game lands. What you could do in that case, where essentially you have a whole lot of smaller game lands, which might be part of the same administrative unit, is you could look towards another statistic such as high suitability value or medium suitability value, which is less area bias. And that would still get you, I believe, the results you're looking for.
If I could just follow up, Samara, I think to sort of directly answer your question, it doesn't currently lump game lands. So it does split along just like the game land administrative designation. With that said, and Liam, if you like hover over a game land, just so we could see, that landscape suitability index, you know, it would be simple as I think just adding them together. If you had two game lands in a particular circumstance that you know are managed, like co-managed, because it's literally, you know, a summation of the total potential habitat within the game land. So you could add them together on a case-by-case basis if you needed to. I think on our end, you know, that boils down to kind of like a pretty locally specific scenario, and leaving them split gives more flexibility than trying to lump together.
Okay, thank you very much.
You're welcome. Liam, there was another question in the chat from Justin that asked about incorporating DCNR lands into the app. And I think the short answer right now is we didn't necessarily plan to go beyond the state game lands in terms of what's actually projected in the app. But the important note to make is that going along with this, we'll be packaging up all the underlying geospatial layers that are incorporated into WPAST and submitting to the agency. So all of those underlying GIS layers are available. And I could imagine any sort of custom application could be done with them.
Yeah, that's our plan. Is in the future, we're going to be working with our GIS staff to get this on our GIS system, and then we can add DCNR lands in there with Game Commission lands as well.
Liam shared the app, and so everybody is now. This is actually why we wait until the end of the presentation to share the link for the app, because we know how interesting it is to play around with.
Yeah, so if you didn't see it, Liam put it in the chat, the link to the app.
Question for you, it's Steve Bernardi.
Go ahead, Steve.
Yeah, do you have other map over like a topo to show what your terrain is and where the higher usage area may be versus, you know, the whole game land?
Yeah, that's a good idea. We can definitely make sure that we have topo when we bring it into our system. Liam, is that something that could be easily done for you? It looks like you can see kind of the hill shape with this map as is.
I can take a look at it. Let's see.
Liam, if you go in close, do you get contour lines on that Esri topo?
Unfortunately not. It may be something that can be incorporated into Leaflet directly. Take a look at it.
At the very least, we'll definitely make sure that's available when we bring it into our GIS system.
Liam, Justin asked about the pixel size.
270 meters.
And maybe that's a good
Yeah.
prompt to just say something about pixel aggregation.
Definitely. So one thing that we very much discourage when using this application is zooming in on a single pixel and making inferences based on that. So for example, not seeing a whole lot of like single pixel spikes in here. But say if there was like a single red pixel within this game land, deciding you just want to manage right where that one red pixel is, that's a bad idea. So instead, what we recommend doing is taking larger chunks of the game land, specifically chunks that are 4 pixels or 1 kilometer in size or larger, and making judgments based on this. So say this chunk here on game land, well, I guess right south of game land 100, which is at least 1 kilometer tall and maybe 1 kilometer wide as well, would be an area that you would want to make a judgment based on, instead of say the smaller areas like right down here that really aren't that large at all. And so the reason this is the case is because WPAST is created using these larger landscape scale variables, which are often making inferences based on what's 1 kilometer or 5 kilometers or 10 kilometers away. And so those small individual pixels really don't end up meaning all that much. And that's detailed fairly extensively in the manual. And I'm happy to answer any other questions about it.
So one thing I'd like to add is this is meant to help you guys. We're not telling you that when you see a red spot for woodcock that you need to be managing for woodcock in that area. It's meant to help you in developing your plans and managing your property if you have an interest in woodcock. And maybe Scott, you can go into more of how you see this being used, Scott or Tim, how you see this being used in game lands planning.
Well, I think at this point, it's more of an introduction, but we certainly hope that you all kind of get your nose into the tool and start factoring it in as you're developing, your plans for projects. Certainly a lot of these projects will be PR reimbursable if they're not directly associated with commercial timber harvests. But do be thinking about the different types of management as it relates to both migratory habitats and breeding habitats. And then certainly if you have questions, don't hesitate to let us know. I will just say, as we're moving forward, we are going to be sharing this recording, this webinar with we'll have it on the H drive. Liam will have it in his tool, and we'll have it in a couple other places. So we'll be sharing this after today.
There's a question in the chat. Where's the best place to find info about ideal breeding and migratory habitat? And if whoever asked that wants to elaborate, if I go in a direction that you weren't actually looking for, go ahead. But the app here is sort of operating, as Liam has said, on like this landscape scale. So we're looking at things like how do habitat used during stopover versus habitat during breeding vary based on big picture landscape composition, land cover, landform, soil moisture kinds of things. What it doesn't necessarily do, and Liam alluded to this during his presentation, is, on the ground, like what's the species composition, forest structure, things like that the birds are relating to, that you would maybe target a little bit more in a habitat management context. So for that later piece, we still have to rely on what exists in the literature so far. Like as suggested here, Chapter 15 in the Wildlife Habitat Manual, some of the classic woodcock management literature, et cetera. And, as we move forward with the data that we have collected as part of the Woodcock Cooperative, we certainly hope to continue to inform that, because we're in a unique position, especially on the migratory piece, to better understand habitat use. But in terms of the predictions in the app, we're really focusing on those landscape scale factors.
Can I jump in on
Please.
the Appalachian Mountain Young Forest Initiative through the Wildlife Management Institute? So if you go to youngforest.org, you can find that. That has a lot of great information about managing certainly breeding habitat specifically. And there's lots of resources on associated with that initiative, as well as the broader youngforest.org website. I don't think there's much out there about migratory habitat, just because there hasn't been a lot of research, and the research that has been conducted hasn't really been converted into like best management practices yet. So that's probably an important need, is coming up with some migratory habitat recommendations for a future to-do list.
We know, anecdotally that they will use very different habitat during migration. They're more apt and more willing to, settle in more mature forests, for example, than you would expect to see them use during the breeding season. Does that mean that that's providing the best habitat for them? That's the big question. I can say anecdotally from my woodcock hunting, I see big flights of birds here in Maine in the same good young forest habitat that you would find birds breeding in. So I do think there is still an element during migration of, if you build it, they'll come. But I think what we tend to see is, these birds are making flights of hundreds of miles during migration, and there is some element of where they drop out of the sky is where they're gonna find the best thing that they possibly can. And I think it's reflected a little bit in the fact that when you switch between the breeding season model that Liam had up earlier and the migratory model here, the sort of like hotspots get smaller. And we think that reflects the fact that they're making decisions at a smaller scale, because it's much more about, I'm coming down from my migration flight and I'm zeroing in on a nearby landmark and going to that. Versus sort of like a broader degree of choice that's happening as they're choosing a breeding site. And I think this kind of just segues into a question that Justin had. The hotspots that Liam showed during the presentation, Justin, those are generated from all of the stopover locations that we've collected across the entire project, both spring and fall migration. So what it boils down to is there's a very major corridor along the Atlantic coast that the birds are moving up and down, but then birds that are ultimately going to end up breeding in Pennsylvania, New York, Ontario, or even like filtering over to the Great Lakes and the Midwest. At some point, they're breaking off that Atlantic coast corridor and moving out across, and that's where you see kind of like the islands of stopover occurring away from the coast.
And I've added some links to the chat box of some of the resources that I mentioned.
Eric, this is Phil Casper. One question about Gamelands acreage. When you go to the Gamelands Within View tab and zoom into, any particular Gamelands, some of those acreage numbers seem to be incorrect.
I can go back and verify these just to make sure that everything's working like it should.
Yeah, so like Gamelands 100 has 21,000 acres, roughly.
Okay. Maybe in different units. I'll take a look. Thank you.
Okay, thank you very much.
You'll have to double check that. I assume that's a shapefile, Liam, that we obtained from the Game Commission, right?
It would have been, I think, publicly accessible on the website.
Just say offhand, it shouldn't change anything about the
No.
calculation of the metrics and sort of their relative difference among each other. It just, yeah, like Liam said, it might be that we got the units wrong, which is embarrassing, but we'll fix that. Justin asks a good question about different habitat selection during spring and fall migration. About the only thing that I would say might change that a little bit is like males on their northward migration are definitely displaying as they go. And so there's going to be an element of selection for singing ground areas, but that's going to be a fairly local scale selection during the spring migration that you wouldn't see during the fall. What it boiled down to for us in generating these models is that we felt there was greater utility in pooling the data so that we had a more data-rich source for generating the migratory habitat layers. And, you know, sort of setting aside that one kind of like specific thing about male display, we didn't necessarily, there wasn't any, at least at this point, a priori. Yes, fall and spring habitat are fundamentally different. And so, you know, it passed the straight face test to pool. So we kind of take an assumption that true stopover habitat as they're going is going to function largely the same. And it's helped out by the fact that, you know, unlike say a migrant songbird who's relying on like fruit resources during fall migration that don't exist during spring migration, where there might be like really big habitat differences there that drive selection. I think with woodcock, you know, just with them as an earthworm specialist, we think maybe less importance of that. One other thing I'll say just out loud as I'm thinking about it, and it's relevant to that question, something that Liam didn't mention during his presentation, but that's contained in the user's manual, or at least references that Liam did go through a pretty extensive cross-validation procedure in this to ensure that these models, you know, aren't just pretty maps, but they have some pretty good predictive accuracy. And that was through a process of basically building the model and withholding a data set or a subset of the data and looking at how well it was predicted and then iterating that. So we did go through at least a statistical procedure to validate that, in fact, you know, these models have good predictive accuracy, which was an important step to make us feel good about using them for prediction.
All right, do we have any other questions?
Are we going to be able to share this with the rest of our staff after this meeting?
Yes, as Liam had the chat or put the link in the chat, but we can send that out to everyone as well so that you can just email it out. Anybody is that the best way, or would somebody like that link in a more specific spot?
I think we can send it out to the group that received the email blast. And then, I mean, by all means, feel free to share this. And, you know, going back to your point, Ken, I think, you know, about comprehensive management plans, I certainly hope that this drives a lot of engagement and interest. Please do, you know, spend some time playing with the tool, looking at it, seeing what kind of ideas it generates. Certainly work with your comprehensive management planning team, your colleagues in your region to generate some ideas for projects in the context of both the migratory and the breeding habitats. Certainly, chapter 15 of the habitat manual will help give you some information. Amber has some web pages here. Get your, look into the literature, spend some time reading on what these habitats could or should look like. But yeah, we can share the tool with the email, and certainly feel free to share it amongst your colleagues. Liam, I do know that you had changed the landing page for this. Do we anticipate that we're locked in here for the landing page? Is this going to be pretty permanent?
Yeah, this is where the URL is going to be. Yeah, it'll be here.
Okay. All right.
Scott, Samara asked if we could put this on Habitat page on the intranet.
Yeah, we can certainly do that. As you guys may know, marketing is in the process of hiring and bringing on board a new web page person. So they have a couple requests from us right now that they've tabled. Hopefully, once that new person starts, we'll get a bunch of different things listed and posted on to the Habitat page. But absolutely, we'll certainly have this there.
Hey, just one other quick thing, Scott. And
Yeah,
everyone.
Phil.
I've been fortunate enough to be part of this from not the inception, but quite a while now. And the Northeast was lucky that we were able to utilize some of the WPASS data already to help us put together Woodcock-centered projects. Some of it was, we had some anecdotal observations of woodcock in areas, and then the WPASS tool concreted those observations as good places to do habitat work. So, a testament to it works in our region, so it'll probably work elsewhere with good confidence.
That's great, Phil. Thanks.
Yeah, and Phil, we were actually really excited on our end to see it put to use basically as soon as it kind of like rolled off the assembly line. So thanks for that.
Absolutely. One interesting note, especially for you, Eric, knowing you're a woodcock hunter, we had a meeting with some of our land management staff on a game lands in Susquehanna County, specifically to kick off our woodcock restoration initiative here. And as we were talking in the parking lot, a hunter was getting back to his vehicle, and he had just harvested a woodcock in an area that we're planning to do some habitat work in. So kind of full
Great.
circle.
Yep, that's great.
Phil, maybe now would be a good time. Do you want to talk a little bit more about your process on how you identified those project areas and how you moved them forward? I don't want to put you on the spot, but if you have some insights that might be helpful for the group.
We took a pretty simplistic approach. Some of the sites, the land manager or his crews have seen woodcock there. They have those anecdotal observations. Their existing old field type habitats or the transition between field and forest or shrubland complexes. And so we had a history of knowing that woodcock do exist there already. And then other areas were, in particular Game Lands 219, where we've done a lot of our banding and satellite transmitter work. So we knew that woodcock were there already, and the habitat's pretty good, but we're faced with lots of invasive vegetation that we just haven't been able to get a hold on. So our first step was, understanding the issues on the site, and then what can we do to alleviate it. So most of what we've done so far has been or will be herbicide work, prior to the end of this fiscal year on about 70 some acres. And then next fiscal year, we're hoping to target about 261. And it's basically existing woodcock habitat, and we're hoping to make it better.
And this is Kevin Wenner. I'll just add to that. Part of the information that we used were some of the singing ground surveys that we set up probably upwards of 10 years ago, that were established to kind of gauge some of the habitat work that was already ongoing on certain game lands within the region. And the tool just kind of overlaid perfectly with what we were already trying to evaluate there, and was kind of the really strong justification for us pursuing the funding that we were eligible to receive.
Yeah,
Great.
thanks for that, guys. And also thanks
Yeah.
for being the guinea pigs on this. You got to see the very early drafts, and I think really helped us like with this final draft. You had some very good suggestions on how to make this more usable for you all in the field. So we really appreciated that. All right, well, I don't see any other questions, so I want to thank you all again for joining us today to learn about this really cool new tool that we have out here for Woodcock. And big thank you to Dr. Blomberg, Dr. Roth, and Liam for working with us on this. It was great to work with you guys on it, and this is a really high quality project. So we really, really appreciate what you did for us here. So thank you.
Thank you, Ken. Really pleasure to work with you all.
Yeah, thank you all. It's been real fun.
Thanks, guys.
Hmm.
All right. Well, I guess we'll be done then. Thank you.
Bye.
See y'all.